All right, last one of 21. So 21.3, angle similarity. So I get to determine when two triangles are similar using the angle similarity postulate. So just as a reminder, we've talked about similar figures, but they have the same shape but may have different sizes. And something to be considered similar would be that their corresponding angles are congruent. Remember, that means equal. Okay? And the lengths of the corresponding sides are proportional. So that's just like when we did in dilations, that remember their lengths had to all reduce to the same amount, or they were all changed by the same amount. All right, so the angle similarity postulate states that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. That's why it's just angle. Two angles have to match, and then the angles are similar. Okay, so we have these two triangles. We can see that B and E are congruent, right? Angle B is congruent to angle E. We can see that. But what we don't know if A and D are equal, and we don't know if F and C are equal. So remember from 21.2, we know that all triangles have 180 degrees. So we can do 45 plus 100 plus my angle C and see what angle C equals. This is just from the last lesson. So I would go 145 plus angle C equals 180, and then subtract my 145, and it says that angle C does in fact equal 35 degrees, and now I have two angles that are congruent. So now I also have angle C is congruent to angle F. So I have two angles that are congruent. I've proven it by solving for this. And so now I have two angles. So we can say triangle ABC is similar to triangle. And these have to match. So since B is down the middle and E is its congruent, I need to put E in the middle. So I'm going to go D, E, F. So that means A is equal to D, B is equal to E, and C is equal to F. And this symbol means, similar. Just half an about symbol. That means similar. So there we go, we've proven it. They are similar. Okay, so what's the point of deciding if two triangles are similar? Well, real world stuff comes in handy. So Rosie is building a wheelchair ramp. She wants the total length to be 24 feet tall, or long, and 2 feet tall. She needs to install a vertical piece, support piece, 8 feet from the end of the ramp, but she's not sure how tall the support piece is going to be at that point. So she wants to be able to measure it and put it in there beforehand, right? Not guess and check. So the first thing we have to do is prove that these are similar. So we have one small triangle right here, but we have an overlapping big triangle right here. I know I didn't line the angles up perfectly. If you notice, they share this angle. So right there, I have proof that they share one angle. They have one angle in common. Now I need to prove that they have another angle that is congruent. This is a right angle. This is also a right angle. So there's my two congruent angles. The corner here and this corner here. My right angles and the angle they share. So now that I've proven that they are similar, these triangles are in fact similar, I can then solve them using a proportion. We always have our proportions be small compared to big. That way it just stays consistent. Okay, small triangle piece to big triangle. So what it would look like is I want to compare their lengths small length compared to big length. And that's going to be equal to the small height compared to the big height. I just realized that I tried to spell that wrong. I don't know, you guys. I'm confused. No, that's right. All right, so the small length is 8 feet. The big length is 24 feet. We're going to compare that to the small height is the one we don't know compared to the big height of 2 feet. Okay, this is where we use cross products. Multiply across. So we're going to get 24h equals 16 feet, which I don't need to put the feet. So remember that. There we go. We're going to divide by 24. So you can divide and get a decimal. We can also reduce, which could make it easy. I could just divide them both by 8. And I would say the h is equal to 2/3 feet. Right, I divided both of these by 8, just reducing it. If you used a calculator and actually divided, you got 6/10 repeating, which makes it a little difficult to measure in real life, right? I can measure 2/3 of a foot, but it's going to be really hard for me to measure 6/10 repeating of a foot. So that's why leaving it as a fraction would probably be best. All right, so things to remember. First, prove that they are similar. Prove the triangles are similar. Second, solve using a proportion. And then remember, it's small triangle compared to big triangle, just to keep it consistent. Okay, so the lower cable meets the tree. I cut off some of this. These are cables. I think I cut off part of this question, so I apologize. The lower cable meets the tree at a height of 6 feet. Height is this way. This is not a height. We would call that like a slant height, or an 8, like a just normal length. And extends out 16 feet from the base of the triangle. This right here, is not drawn very well, is 16 feet. If the triangles are similar, how tall is the tree? So, how are they similar? Are they similar? And then also, go and set up your proportion like we just did in the last example, and tell me how tall the tree is. All right, until next time.